Hey everyone, welcome back to Building Cyber Resilience. I'm genuinely excited to continue this journey with you as we tackle one of the most challenging aspects of cloud security. We've covered the basics in our previous sessions, and honestly, I think we've built a solid foundation together. Today, though, we're diving into what I believe is the absolute heart of any cybersecurity program, protecting your data in cloud storage. Here's the thing that keeps me up at night, and probably should keep you up too. Data really is everything for your organization. I'm talking about customer information that people trust you with, the intellectual property that gives you a competitive edge, financial records that auditors scrutinize, and all that operational data that keeps your business running. When any of this gets compromised, the fallout can be brutal. We're talking serious financial hits, reputation damage that takes years to recover from, and legal headaches that nobody wants to deal with. Today, I'll walk you through securing the main types of cloud storage you'll encounter: object storage, block storage, and file storage. We'll look at examples from the big three providers: Amazon Web Services, Microsoft Azure, and Google Cloud Platform. And I'll share some hard learned lessons about data encryption and access controls. Trust me, these aren't just nice to have features anymore. Before we get into the technical stuff, let me explain something that trips up a lot of people: the shared responsibility model. This concept appears straightforward on paper, but the reality is more nuanced than most organizations realize. Your cloud provider, whether that's AWS, Azure, or GCP clouds, handles the security of the cloud. They're responsible for the physical infrastructure, the network backbone, and the underlying services that power everything. But here's where it gets interesting. You, as the customer, own the security in the cloud. This includes how your data is stored, who can access it, and how it's protected. Now, here's a statistic that might shock you. Industry analysts predict that 99% of cloud security failures through 2025 will be the customer's fault. That's not the cloud providers failing, that's us making mistakes, often through misconfigurations that seem minor but have major consequences. This reality underscores why understanding your role in data protection isn't optional anymore. If you wish to learn more about shared responsibility, I made a video on this topic. You can find the link in the description below. Now, let's talk about multi-layered defense strategy. I've learned, and sometimes the hard way, that data protection needs to happen at three critical stages: in transit, at rest, and in use. Let me break this down. First, the encryption in transit. It protects your data while it's moving across networks. Think of it as putting your data in an armored truck while it travels from point A to point B. Then, encryption at rest. It secures data when it's just sitting there in storage, whether that's on disks, in databases, or in object storage buckets. This is like having a really good safe for your important documents. Lastly, encryption in use, sometimes called confidential computing. It is the newest piece of this puzzle. It protects data while it's actively being processed in a server's memory. This is harder to visualize, but imagine being able to work on sensitive documents while they remain encrypted the entire time. This approach, which security professionals often call defense in depth, creates multiple layers of protection. If an attacker manages to break through one layer, others are still there to stop them. Here's a practical example. Even if someone breaks into your network and steals what appears to be critical data, if that data is properly encrypted, you might not even have a breach under regulations like GDPR. That's the real power of encryption. Now let's talk about where most organizations would start to secure object storage. Object storage tends to be the first cloud storage type that organizations encounter, and for good reason. It's perfect for unstructured data like images, videos, backups, and large data sets. The way it works is pretty straightforward. Your files, which become objects in cloud terminology, get stored in buckets, logical containers, and you access them through HTTPS, command line tools, or programming interfaces. The major cloud providers all have strong object storage offerings: Amazon S3, Azure Blob Storage, and Google Cloud Storage. These services can provide incredible durability and availability. But here's the catch. Their security depends almost entirely on how you configure them. To secure these object storage, here are some essential security practices. 1. Encryption isn't negotiable anymore. I can't stress this enough. Encrypt everything, both in transit and at rest. For data in transit, make sure you're using TLS 1.2 or higher. If you're still using TLS 1 or older versions, you're basically asking for trouble. Disable those immediately. For data at rest, you have several options. Cloud providers offer server-side encryption SE, where they manage the encryption keys for you. Alternatively, you can use customer-managed keys through key management services like AWS KMS, Azure Key Vault, or Google Cloud KMS. These services are specifically built for this purpose and generally do a better job than rolling your own solution. There's also client-side encryption, CSE, where you encrypt the data before it even leaves your environment. This gives you maximum control but requires more technical expertise to implement correctly. 2. Access controls require constant vigilance. Therefore, implementing bucket policies to define permissions seems straightforward, but the devil is in the details. You need to be extremely careful about who can read, write, or delete objects. I've seen too many organizations get burned by overly permissive policies. Here's something that should terrify you. Misconfigured public access is still one of the leading causes of data breaches. Unless you have an explicit business need for public access, and even then, think twice, block it completely. The principle of least privilege isn't just a best practice, it's a survival strategy in today's threat landscape. 3. It is about versioning and lifecycle management. Enabling versioning on your buckets creates a safety net that has saved countless organizations. When someone accidentally deletes or overwrites an object, or when ransomware strikes, you can revert to previous clean versions. I've personally seen this feature prevent what could have been catastrophic data loss. Lifecycle policies help manage storage costs while meeting data retention requirements. These policies can automatically move data to cheaper storage tiers or delete it after specified periods. This isn't just about saving money, it's about implementing proper data governance. 4. Data classification matters more than you think. Before you store any data, you need to classify it based on sensitivity. We're talking about personally identifiable information, credit card details, healthcare data, and intellectual property. Each type of data may require different security measures. Here's a practical tip that might save you from embarrassment. Don't enter PI or sensitive data into public AI platforms like ChatGPT. I know it's tempting to get quick help with data analysis or formatting, but this can create serious compliance issues. 5. The security of application programming interfaces and credential management are critical aspects to consider. Since most object storage access happens through APIs, securing these interfaces is critical. Use secure application programming interfaces and manage your credentials properly. I strongly recommend leveraging managed secret services like AWS Secrets Manager, Azure Key Vault, or Google Cloud Secret Manager. These services can automate credential rotation and provide secure storage, which eliminates a lot of manual security work. Now you have secured your object storage. So what is next? Monitoring is next. Continuous monitoring isn't optional in today's threat environment. Each cloud provider offers native auditing services, AWS CloudTrail for Amazon S3, Azure Monitor for Azure Blob Storage, and Google Cloud Audit Logs for Google Cloud Storage. Enable data access audit logs, especially for sensitive environments. Yes, this increases storage costs, but the ability to perform forensic investigations and incident response makes it worthwhile. These logs often provide the only way to understand what happened during a security incident. Here's something crucial that many organizations miss. Store your audit logs in immutable storage. This prevents accidental deletion or tampering, even by malicious insiders. Look into Amazon S3 Object Lock, Azure Blob Storage Immutability, and Google Cloud Storage Bucket Lock for this functionality. I recently heard Sean McCloskey, Chief of Cybersecurity for CISA Region 4, emphasize that companies hit by ransomware attacks often lacked good offline backups. While immutable storage for logs is important, remember that offline backups for your actual data remain absolutely critical. Next in our list to secure is block storage, the virtual disks. Block storage provides raw disk volumes that attach to virtual machines, similar to traditional storage area networks, SANs. You can format these volumes with familiar file systems like NTFS or XT4, then use them for operating systems, databases, or application files. The major examples are Amazon Elastic Block Store, Azure Managed Disks, and Google Persistent Disk. These services provide the foundation for most cloud-based applications. Here are the key security practices for block storage. 1. Encryption as the first line of defense. The most important security measure for block storage volumes and their snapshots is encryption, and it needs to happen before you start using the volumes. This ensures that even if someone gains physical access to the underlying disk, your data remains protected. Use AES 128 or stronger encryption standards. Most cloud providers now offer options to encrypt volumes by default or let you use your own KMS keys. I recommend taking advantage of these features from day one rather than trying to retrofit encryption later. 2. Virtual machine security is block storage security. Since access to block storage typically happens through the guest operating system running on your virtual machine, VM security becomes paramount. This creates several security requirements. You need strong identity and access management for anyone accessing the VM. Network access controls should restrict inbound and outbound traffic to only what's necessary. Regular patch management for the OS and applications becomes critical for addressing vulnerabilities. Don't forget endpoint protection software on the virtual machines to detect and respond to threats. 3. It is about snapshot management and the required discipline. Taking regular snapshots of your block storage volumes provides backup and recovery capabilities, but these snapshots need the same security attention as the original volumes. Ensure snapshots are encrypted and that access is strictly controlled through identity and access management policies. Here's something that often gets overlooked. Regularly test your backups to ensure they actually work. I've seen too many organizations discover during an emergency that their backup strategy looked good on paper but failed in practice. One type of block storage is auditing block storage. This storage typically ties into your guest OS capabilities and your cloud provider's logging of management activities, creating, deleting, attaching volumes. Make sure audit logs from your virtual machines flow into your central logging service for comprehensive monitoring and threat detection. One of the most used storage type is file storage. They are used to share file access in the cloud. File storage brings familiar network, attached storage, NAS functionality to the cloud, allowing multiple compute instances to share access to the same file system. This becomes particularly useful for applications requiring shared file access, such as content management systems, developer tools, or user home directories. The main examples are Amazon Elastic File System, EFS, Azure Files, and Google File Store. These services bridge the gap between traditional file servers and modern cloud architectures. The security best practices for file storage are 1. Access controls and permissions. File storage services offer various mechanisms for managing access, typically based on file shares, users, and groups, similar to traditional file servers. Implement access controls using IAM policies to control which users or services can mount and access the file system. Network access controls should restrict network access to file shares only from authorized virtual networks or subnets. This creates multiple layers of access control that attackers would need to bypass. 2. Encryption everywhere. Always encrypt data at rest within your file storage. Cloud providers offer integrated options, often working with their KMS services. Ensure data stays encrypted in transit when accessed by compute instances. This often happens automatically through underlying network protocols or by keeping communication within a secure virtual private cloud. 3. Centralized logging and auditing integrate your file storage services with centralized logging services like a WS CloudTrail for Amazon FSx, Azure Monitor for Azure Files, and Google Cloud Logging for FileStore. Monitor for unusual access patterns, permission changes, or excessive data transfers that might indicate a security incident. 4. Maintenance and patching. Although file storage services are often managed by the cloud provider, any underlying file servers or client machines accessing them need regular patching and updates to address vulnerabilities. This shared responsibility model means you can't assume everything is automatically secure. Securing data in cloud storage requires consistent application of core cybersecurity principles across all storage types. Data encryption and access controls form the foundation, but they're just the starting point. Beyond technical controls, the importance of good backups, especially offline backups, cannot be overstated. These backups provide your fastest path to recovery from ransomware attacks and other disasters. But here's the key. Regularly testing your backups isn't just a good idea. It's essential for ensuring your data can actually be restored when needed. I've worked with organizations that discovered during a crisis that their backup strategy had critical flaws. Don't let that be you. Schedule regular backup restoration tests and document the process so multiple team members can execute it. By implementing these data safeguarding measures, encryption, access controls, comprehensive auditing, and reliable tested offline backups, you transform your cloud storage from a potential vulnerability into a resilient defense system. This represents what cyber resilience really means, not just preventing attacks, but ensuring you can recover quickly and completely when attacks succeed. Thanks for sticking with me through this detailed exploration of cloud storage security. I know it's a lot to absorb, but these fundamentals will serve you well as cloud environments continue to evolve. In our next sessions, we'll explore more advanced cloud security concepts, specifically cloud native application protection platforms and cloud security posture management. These tools represent the next evolution in cloud security management, and understanding them will help you stay ahead of emerging threats. Make sure to check out our accompanying blog post for more detailed configuration examples and actionable steps you can implement immediately. I'll see you next time, and as always, stay secure out there.